Good afternoon, viewers. In this video, we are going to discuss the production possibility frontier, otherwise known as the production possibility curve, which is an economic model that seeks to illustrate the trade-offs and opportunity costs associated with producing various combinations of goods and services in an economy. In the first part of this lecture series, we discussed the concept of scarcity and how scarcity is the basic factor that gave rise to the study of economics, and how scarcity bred choice and scale of preference, ultimately resulting in opportunity cost. Today, we are going to use the aid of production possibility frontier or production possibility curve to demonstrate how it is a possibility that given a limited resources or limited factors of production and a given level of technology, it is a possibility that production of goods and services will get to a point beyond which it becomes impossible to increase the production of one commodity without reducing the production of another commodity. To achieve this, we shall define the production possibility frontier. Then we briefly look at the various assumptions underlying the production possibility. Then we briefly look at the various assumptions underlying the production possibility model, after which we'll derive a production possibility schedule, which is a tabular representation of the various combinations of goods and services that can be produced given the specific resources of that economy. Once we are done with that, we will represent the production possibility schedule in a graphical form, thereby giving us what is called the production possibility curve, or the production possibility frontier, or the production possibility boundary. By way of definition, production possibility frontier can be defined as a graphical representation of the maximum combinations of two goods and services that can be produced in an economy using the available resources in that economy. Let's take the case of a hypothetical economy known as country A. Country A. And let's assume that country A produces only two goods and services: bicycle and computer. Two goods, bicycle and computer. We understand that country's economy produces various goods and services. But for the sake of this analysis, to simplify this analysis, we are going to assume that country A is producing only bicycle and computer with its resources. Let's simply assume that country A has fixed factors of production or fixed input in terms of resources used in producing goods and services. To be specific, let's assume that country A has, say, 20 units of labor, 10 units of capital, and 50 units of other factors of production or other raw materials. So country A has 20 units of labor, 10 units of capital, and 50 units of other raw materials. These are what we call resources or factors of production. Let's further assume that these factors of production are available to country A, that the factors of production are not equally efficient in the production of all goods and services. By this, we mean that the factors of production are not perfect substitutes for each other. Hence, some factors of production are more suitable for the production of bicycle, while other factors of production are better suited for the production of computer. Let's be more specific. Assuming that out of the 20 units of labor that country A has, let's say that 10 units of labor are professionals. Less than 10 units of labor are professionals in bicycle production, meaning that they are experts when it comes to producing bicycle, and the remaining 10 units are professionals in computer production. That's not to say that the categories of people are novice when it comes to producing other goods and services, but when it comes to the goods and services that they can produce efficiently, we say that 10 units of labor can produce computer efficiently while the remaining 10 can produce bicycle efficiently. That does not mean that some of these inputs cannot be switched to producing other things, but if those that are experts in producing bicycle are switched into producing computer, they will become less efficient. And the same thing happens when those that are experts in producing computer are switched to producing bicycle. Though they still produce bicycle, but they will do that less efficiently. Let's further assume that the level of technology existing in this economy in country A is constant. By technology, we mean the method, techniques, or processes of producing goods and services. And when we mean constant technology, we mean that these processes or techniques do not change over time. Take for instance, if country A is using, let's say, crude farming equipment such as hoe, cutlass, shovel, and digger, by constant technology, we mean that within the period of this analysis, that country A is not going to switch into the use of better technology such as tractor. Hence, we are assuming that within the period we are going to confine our studies, the technology available for country A remains the same. So there are no improvements in technology, either increase or decrease in technology. Finally, let's assume that in country A, all the factors of production available, including the labor and capital, are all efficiently employed. Hence, there is no unemployment in country A, and all the capital available are being fully utilized. There is nothing like suboptimal utilization of any of the capital. Given the following assumptions, we can proceed to draw or to derive what is known as production possibility schedule, which, like I said earlier, is the tabular representation of the various combinations of goods and services that an economy with the characteristics I have mentioned above would produce. In the hypothetical table above, as you can see, we assume that this economy, which is country A, that control A has given amount of resources, which, like we said earlier, that country A has 20 units of labor, 10 units of capital, and 50 units of other raw materials. And given these constant units of input, that country A can either produce computer or it can produce bicycle. This table shows us the various combinations of computer and bicycle that country A can produce when all the factors of production available are fully utilized. And as resources are being switched from production of one commodity to the other, we see that the trade-off becomes evident, as you can see here. For instance, when country A produces 20 units of computer using the available resources, it cannot produce any bicycle. So for country A to produce 1 unit of bicycle, he has to only produce 18 units of computer, meaning that 2 units of computer are going to be sacrificed, which is what we have the marginal opportunity cost here. The marginal opportunity cost, as we will later visit it, is the sacrifice of one commodity for us to produce an extra unit of another commodity. So, but to increase the production of bicycle from 1 unit to 2 units, country A have to only produce 14 units of computers. Hence, from 18 to 14, country A is sacrificing 4 units of computer to produce another 1 more unit of bicycle. To produce an extra 1 more unit further from 2 to 3, country A can only produce 8 computers, meaning that it is going to sacrifice 6 units of computers to produce an extra 1 unit of computer. While for country A to produce 4 units of bicycle, it will not produce a computer at all. Meaning that if country A channels all of its resources into the production of bicycle alone, it can only produce a maximum of 4 bicycles. But if you combine, if it channels all the entire resources into the production of computer, it can produce a maximum of 20 computers. That's when it did not produce any bicycle at all. Hence, in between 20 bicycles, in between 20 computers and 4 bicycles, we have various other combinations of bicycle and computer that country A can produce when all the factors of production available have been fully utilized. The above hypothetical schedule can be plotted in a two-dimensional graph wherein we are going to have the number of bicycles produced on the x-axis and number of computers produced on the y-axis. This is a two-dimensional graph, and we are going to have computers on the y-axis, computers, this is y-axis, and we are going to have bicycle on the x-axis. So we are going to have a calibration. We're going to calibrate here 1, 2, 3, and 4. The distance might not be equal, but it's going to give us a little approximation of what we would get if we had used the real graph book to do our plotting. So in this case, let's calibrate 2 by 2 scale. 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. As was shown by our schedule, when country A produces only computer, it produces the 20 computer and 0 bicycle. But when it produced 18 computer, it was able to produce 1 bicycle. So we can't trace this down. But for this country to produce second bicycle, it can only produce 14 computer. So we trace 14 computer to 2 bicycle. When this country wanted to produce an extra bicycle, it could only produce 8 computer and then 3 bicycle. But for the country to produce 4 bicycle, it did not produce any computer at all. So we can join all the possible combinations as we have here so that we will obtain a graph. When we join all these combinations, possible combinations of computer and bicycle, both from the x and y axis, we obtain what is called the production possibility frontier or production possibility curve. Production possibility curve, which is more or less like a boundary that shows us the maximum combination of computer and bicycle that country A can produce given its available resources. From here, you can see that here is point A, and at point A, country A only produces 20 units of computer while they must produce bicycle. But at point B, country A produces 18 units of computer and 1 unit of bicycle. At point C, country A produces 14 units of computer and 2 units of bicycle, while at point D, country A produces 8 units of computers and 3 units of bicycle. Then at point E, country A produces 4 units of bicycle without producing any units of computer at all. This is exactly what is referred to as the production possibility frontier, and it shows the various combinations of computer, like I said, and bicycle that can be produced within this economy, given the limited factor of production. Now, in between, we can find several other combinations of computer and bicycle. For instance, if we take 12 computer and you get to the plot, it will align with say 2.5 bicycle. If there is anything like that, assuming we have 2.5 bicycle, We can say for you to produce 2.5 bicycle, you must produce what? 12 units of computer. Then if you produce say 6 computer, you are going to produce greater quantities of bicycle. So you are going to be producing say 3.2 units of bicycle for you to produce 6 units of computer. And it continues like that across between 20 and 0 for computers and between 0 and 4 for bicycle. We can have several other minor combinations. As can be seen from the production possibility curve here, the marginal opportunity cost kept increasing as more bicycles were being produced. This is referred to as the law of increasing marginal opportunity or the law of increasing opportunity cost. And this refers to the condition that occurs when more and more unit of a particular commodity is being produced. This law implies that when you decide to make more of a particular commodity, it becomes increasingly more difficult and more expensive to produce that particular commodity. This is based on the assumption that resources are not equally efficient. As we said earlier, that some factors of production, especially labor, were more suitable for the production of computer, while some other factors of production are more suitable for production of bicycle. Hence, to produce higher quantities of bicycle, it requires that more and more factors of production have to be pulled from the production of computers into the production of bicycle. And the more you pull factors of production from computer to bicycle, those factors of production becomes less efficient. Hence, you have to sacrifice more in terms of the opportunity cost of computers to produce an extra unit of a bicycle. Let's take another related example. Imagine you have a limited resources with which you can use to produce either shoes or football. The first shoes you are going to be produce is going to be less costly and easier to produce because you will be using the resources that are more suitable for production of shoes. However, as you continue to increase the production of shoes, the resources that are suitable for production of shoes become smaller. Hence, you need to put resources that are more suitable for production of football into producing shoes. Hence, it becomes more expensive to produce more shoes. Hence, the opportunity cost of producing additional shoes will continue to increase and more shoes are being produced. Finally, we are going to look at whether country's economy will always be producing at the boundary of the production possibility curve or whether the economy can operate under the boundary or beyond the boundary. The question of whether country's economy could always produce at the production possibility frontier, the answer is no. Countries that produce at the production possibility frontier are countries that are utilizing the resources of that country efficiently. However, some countries, it is possible that some resources might be unemployed, some laborers might not have work to do, some machines or capitals might be underutilized. Hence, it is a possibility that though a country has the prospect of producing at the production possibility frontier, when some factors of production are not efficiently being used, such country can produce suboptimally. Hence, it is a possibility that this country A, can produce inside the production possibility boundary. For example, country A can produce 12 units of computer and 1 unit of bicycle. Even though the resources it has is enough for it to produce beyond that capacity, when this happens, we say that the country is producing suboptimally. It is equally a possibility that country A can produce 8 units of computer and 2 units of bicycle, when it is possible for it to produce higher. Hence, any point within the production possibility boundary inside, we look at them as the attainable points. However, country A cannot produce any combination of computer and bicycle beyond the production possibility frontier. Hence, once country A produces at the production possibility frontier, it is producing optimally. However, any point outside the production possibility frontier, like F, requires greater combination of bicycle and computers, and given the available resources, which we assume that it is fixed, it means that the resources cannot enable country A to produce beyond the boundary provided by the production possibility frontier. This is the end of the lecture today. If you enjoyed today's lecture, kindly follow our channel by clicking the subscribe button. Thank you.